Okay, so let's just start. Okay, so we were doing gravitation, and in the previous class itself, what we did this, like the last value, last thing which we did this, right? What is the g or acceleration due to gravity? So this is what we did. So now let's just discuss more about this particular g. Okay, so let's just now, what is the symbol of acceleration due to gravity and what is the value? Right, so of course the symbol, you know that this it is denoted by the letter g. Okay, there are two g. One is your capital G and one is your small g. Okay, so the acceleration due to gravity is represented by this. And what is the value? This value is 9.8 meter per second. Okay, so s minus 2. Over here only you will write m s minus 2. Clear? So quickly write it down. Okay, so what is the syllabus for that, Jasleen? Okay, so we have to like for like most of the things gravitation we are doing, and today we'll be covering till Thursday. Okay, we have to cover this atoms and molecule, right? So what I will do, Justine, I will take your extra class tomorrow. Okay, so can you please tell me when you are available, because tomorrow I am totally packed. Like from 6:30 IST till 10:30, I am totally packed. If you want to, if you want to take, if you want me to take your class after 10:30, then I'm available. But from 6:30 to 10:30, I have my classes. So can you please tell me at what time you are available so that we can discuss this chapter, like atoms and molecules chapter. So are you what is the time difference between your place and India? Is it 2.5 or 1.5? If in case it is 2.5, then we can take your class at 8 o'clock evening. Right, because 10:30 I'll be available. After 10:30 to 8:30 we can take your class. Or else what we can do, in the morning itself, like in the afternoon itself, in between, I guess 3 o'clock we can keep it. So tell me your preferred timings when you are available so that I can arrange a class for you. So 8 o'clock, like in India, it will be 10:30. If it is 2.5 difference, so 8 o'clock, are you fine? Okay, then I'll just ask your counselor, and also in case if they forget to share you the link, you can just drop them a text that as like I have my exam tomorrow, so I want extra class for today. So they'll just remind me. Okay. Okay. So now let's just move to next, which is calculating the value of g. How you calculate the value of g. So let us calculate the value of acceleration of gravity. So as we know that object on or near the surface of the earth is given by g, this, m, r. So this is basically any object near to the surface of the earth. Okay, over here we are talking about only single object. So it is g equals to capital G, m and r square. Okay. Here G is universal gravitation constant, which is constant, which is the this, and m is basically mass of the earth. And what is the mass of the earth? 6 multiplied by 10 raised to the power 24, and r is basically radius. So it is 6.4 multiplied by 10 raised to the power 6 m. Okay, so putting this value in the above equation, right? So over here, this is the formula, right? This is the formula. So you will put G over here, the value of G, the value of M, and value of R. Okay. When you will put them in such a way, you will get this. And this is the value of G. Clear? So if someone asks you to derive from G, derive the value of this gravitational force, acceleration due to gravity, then you are going to do this. You have to remember this. What is the mass of value, mass of earth and mass of earth plus the value of G capital as well as the small g. Okay. So first of all, you will write calculating the value of G. Okay. And after this, I'll scroll it down. Let me know to scroll it down. I'll scroll it down. Okay. Wait. Okay, so now let's just see variation of G. Okay, so as we know that the Earth is not a perfect or a complete sphere. Its radius increases from poles to equator, right? So of course for G you need the radius. So what are the variation over here? So your value of G, it varies on the surface of the Earth. It decreases from poles to the equator, as you can relate from the below formula. Okay, the form over here you have already written the formula. Okay, so you will not write this, as you can relate. Okay, the force of gravity also decreases with altitude. Okay, so basically we are talking about variation of G. Okay, so for example your G is 10. Okay, so what will happen, it decreases from poles to equator. So from, if from here your value is 10, right? So now you are moving to equator, so your value will be 9. Why? Because it is decreasing, right? And coming to the force of gravity also decreases with altitude. So when you goes up above, right? So at that time also your force of gravity also decreases. So this is the variation of G. Okay, now what is mass and weight? So masses can be defined as the amount of quantity of matter present in, right, and body, and the weight is the force, a force exerted by the gravity of the body. So for example, if over here this is a person, so of course gravity is included, so that time this is weight, right? But at that time, for example, I am floating in the air, so at that time that is my mass. Clear? Okay. Now, next is what is the difference between mass and the weight? Okay, so in general studies, often we get confused between mass and weight. Sometimes students think they are the same thing, but no, there is a difference. See, first, the amount of matter present in the body is your mass. Okay, and weight, it is the force exerted by the gravity on a body. Okay, then this is scalar quantity. This is vector quantity. SI unit of mass is kg, but SI unit of weight is Newton or kg meter per second. Okay, mass is always constant or does not change with location, but it change with location, right? So weight changes with location, but mass will remain same. Mass is always constant or does not change with location, it changes with location. Mass of an object can never be zero, but weight in an object can be zero when no gravity acts on it. Clear? So this is the difference between your mass and weight. So you will write it down. Difference between mass and weight. Okay. So last point is basically mass of an object can never be zero. See, in a body you have a mass, right? So that is your mass. You have some weight. No matter whether you are a small kid or a old age person, you have the mass in your body. right? So that can never be zero. But for example, I am floating in the air. At the time, I don't have any weight. That's why I'm floating in the air, right? But weight, this is weight, huh? But this is weight, WEIGST. This is the right error. Weight of an object can be zero when no gravity. For example, nobody is pulling me down, right? So at that time, my weight will be zero. But mass can never be zero. Now it's clear?
Done, ma'am.
Okay. Now, weight of an object on a moon. The moon, in moon, there is no gravity. Okay, so weight of an object on moon. So weight of an object on moon can be defined as the force with which the moon attract an object. So weight of object on moon is one sixth of the weight of the object on the earth. So for example, your weight is 40, right? So in moon, it will be one sixth of 40. Clear? So now the question is, ma'am, why the weight of an object on the moon is one sixth? So since the mass of the moon is less than the mass of the earth, so the moon exerts lesser force of attraction. Okay. So mass on the earth is this, but on moon it is this. Okay. So that's why this is the reason that sometimes they can give you the question what is 1/6. Okay, so 1/6 weight is in, for example, if your weight is 40, then on moon it will be 1/6 of 40. Clear? So you will write weight and object and then this. First question this and then the second question.
School. Finished, ma'am.
Now the next is centripetal phase. So what is centripetal phase? Basically, it's a force that make a body move in a circular path with uniform speed. The force act toward the center. So over here, if, because see, for even have you ever seen that someone is, for example, I am moving my bike like this, right? So why I'm moving it like this? Why I'm not moving from here and there? Why in that circular motion with a constant speed? Which force is acting over there? The centripetal force, because it keeps a balance, right? So this is your centripetal force.
Finished, ma'am.
Okay. Now the next is this. Kepler's law of planetary motion. Okay. So there was a Kepler, of course, a scientist, right? He derived three laws which govern the motion of planets, and these laws are called Kepler's law of planetary motion. So you can see planetary is basically the planets. Okay. So according to his first law, the planets orbit, the planets orbit, not plants. Okay. Wait a minute. Let me just edit it. The planet orbit is an elliptical path with the sun remaining at one of the okay. So basically, sun will remain here, and this they will move all around, right? So this was the first law, and the second law: the line joining the planet and the sun sweep equal area in equal interval of time. So the lines which are joining the planet and the sun, for example, if you are coming from here to here, or from here to here, or from here to here, you will cover equal area with equal interval of time. Okay. Then the third one, the cube of mean distance of a planet from the sun is proportional to the square of the orbit period. Okay, so basically, what is happening? For example, this is the sun and your planet is here, right? So the distance of a planet from the sun is proportional to the square of its orbit period, right? So, however time he is taking, orbit, what will be the you can say orbit will be like this, and over here it's in circular motion. So we are talking about r, right? So it is r cube divided by t square, and which is constant. Clear? So you will write all 3 points. Wait.
Ma'am, can you scroll down? That
Okay. Now moving to this thrust and pressure. So what is thrust? Thrust can be defined as the net force acting on a particular direction. Okay, so net is basically the all the type of forces you are just subtracting them, and in total what you are getting, that is your thrust. Okay, and remember it should be in a particular direction, right? Maybe northward, maybe southward, maybe eastward, whatever it is. And what is pressure? It is the force or the thrust acting per unit area. If you are saying that this is like over here, like in this particular area, this was the pressure, so it is known as thrust. Oh, sorry, this is the thrust, so that is known as pressure. So if you are measuring the force as per unit area, then it is a pressure. Clear?
Finished, ma'am.
Okay. Now, next is pressure in a fluid. So, of course, we are talking about the objects who are in like normal, right? But in fluids, in liquid, what is the pressure? So, fluids are substance that has tendency to flow. Liquids and gases are called fluids because fluids are not only liquids; they are gases because they can flow, right? So, like solid exert pressure due to the weight. Similarly, fluids also exert pressure the base and the wall of the container in which they are kept. For example, you are keeping the bottle over here, there's a water. So it will be exerting force on the wall. And similarly with the gas. So pressure exerted by fluids at a depth is given by P, right? P, and this is the formula for this, right? So this is pressure, this is density of the fluid, and G is acceleration due to gravity, and H is basically the depth. Okay, so this is how you represent the pressure exerted by fluids can be liquid as well as your gas. So quickly write it down, very very important, especially the formula.